There we go. My mic was muted. So, how are you doing? Hopefully, everyone's doing great. If you haven't checked yesterday's video, by the way, we did a live stream. So, in the description, there's going to be like something with the live streams, and if you go there, you're gonna find the one that we did. So yeah, today we're gonna continue with the what was this defense that I was mentioning. We're gonna do the second part. I call this a micro project because it's just a small small little thing. So what we're gonna do now is we're actually gonna export this into Unreal Engine. And I'm going to show you how to create a nice little blueprint. If you've never done blueprints before, then this might be a little bit more advanced. But we're going to do this small little blueprint that's going to allow us to generate, like dynamically generate a long fence. Instead of having to like manually place everything, we're going to be able to just like place this where they're supposed to go. So the first thing I'm going to do is I'm going to zero out all of this, guys. As you remember, we have this wood fence. Whoa. Are they the same? Oh, it seems like they're the same. Let me see. Let me grab like this one. Let's grab like, oh, there we go. So that's A, B, and C. So let's delete everything else. There we go. So what I'm going to do is, first of all, I'm going to zero out their translations to make sure that they're completely at the 0 position. There we go. And we're going to export them, all of them in a single FBX file. So I'm going to say File, Export Selection, and let's go to our projects real quick. So Nexttut Live, let's go to Assets. Let's create a new one, call this wood fence. And here we're gonna call this wood fence FBX. There we go. Now inside of Unreal, this is the scene that I use to do all of my tests and stuff. Here's a little bit of speed tree that I've been teaching some of my students. Here's a very similar process for this, what's this, like a pier or something, like a dock. There's another fence, very similar techniques. A couple of columns. So yeah, it's like my sandbox. And here we're gonna get everything. So I'm gonna go here to my content. I'm gonna create a new folder. Let's call this Nexttut, so that we know that all of our stuff is gonna be here. I'm gonna right click and create a new folder. I'm gonna call this a wood fence. Let's open this one up, right click, and we're gonna import an object here. And we're gonna go into our projects again. So Nexttut Live, Assets, wood fence, and we're gonna import this. Now, very important here, one thing that I want to do is on the mesh, I don't want to combine them. So down here, there's an option here that's called combine meshes. I don't want to combine them, so I'm just gonna hit import, and that way, as you can see, we're gonna get this three fences: wood fence A, wood fence C, fence B, and we have the material. So now we need to very quickly navigate to our texture place. Let me open a new window, because I'm actually going to be cheating. I taught this so long ago. The last time I did this was, let me tell you exactly when this was. Look at this, 2018, 4 years ago. So I don't remember the exact code. We're going to be doing a little bit of review over there. So yeah, let's see. Long ago, I taught like a game creation workshop. Maybe that's something we could do, like a workshop, like a live workshop. I don't think we've ever done like live stuff. I would need, of course, to check if next to this is willing to do this. But we might have, like, we could do like some sort of like live class. Of course, like time management is a little bit difficult all the time, but maybe we can make it work. So here on the source images, we had the textures. Remember the textures that we use for the texturing process. So it was the diffuse, the ambient occlusion, roughness, metallic, and the normal map. So I'm gonna drag all of those three textures right here. As you can see, they're right here. And there's one thing I need to do, very important. This one right here, the ambient occlusion, roughness, metallic, we need to get rid of the sRGB like color correction thing and just save this. It's I'm not gonna go too much into detail. We've talked about that before. It's just it linearizes or delinearizes or actually linearizes the thing so that whites are whites and blacks are blacks, and that way they will behave exactly as I'm expecting it to behave. So this one, the R is the ambient occlusion. There we go. The G is the roughness. There we go. And the blue is the metallic. There we go. And then this one is just a color map. And finally, this one is just the normal map. Simple as that. Just if you ever played that game when you were a little kid, where you put like the triangle and stuff like that, very, very similar process. So it's just about doing that. So we just save, and as you can see, all of our assets right here are gonna inherit the information, and now they're working properly. I have some weird stuff going on here with my light, like the auto thing is just like a little bit too dark here on the previous scene, but it works fine just here. So we can just like literally drag and drop this into the scene, and as you can see, this works perfectly fine. Even the collisions, I think, are gonna work like quite nice. They're not gonna be perfect, but they should be like good enough. There we go. So you can see there's like an invisible box. That's the collision for the object, but for this sort of stuff, that works great. So what we want to do, right, is we want to be able to just like drag and drop any sort of like something here into the scene, and instead of having to manually place and make sure that all of them match, we want to be able to do this in an automatic way. And here's where blueprints come into place. Blueprints are the visual scripting language that we have here inside of Unreal Engine that allows us to work in a very similar way to how like coding works, but without having to actually write code. We're just going to be using logic, which is very important, and that logic will allow me to create a procedurally generated wall. Before we do that though, let me put my songs again. There we go. And this is the code that we're going to be building. All of this thing right here, this procedural wall. So as you can see, it's made out of a bunch of nodes. And if you just see it like this, it's just like, what the hell is this, right? It might look a little bit too complicated. But don't worry, I'm going to show you real quick how all of this works and how we can make this relatively easy. So the first thing is I'm going to create a new blueprint class. And it's going to be an actor blueprint. I'm going to call this BP Procedural Fence. We're just gonna get there. Now, we're not actually gonna be like importing anything here. We're gonna be using other nodes to import our meshes. But one thing that we could do is, where is it? I'm just, okay, yes, we're gonna add one of the fences. There we go. It's gonna be my first fence. And what we're going to do is we're going to go to the construction script. And in the construction script is where we're going to be like creating all of the elements. Now, for this to actually work, we need to create a variable, right? We need to create something that's going to tell us where the fence is going to end. And that's going to be called an endpoint. So we're going to go here to the variable section. I'm going to click and I'm going to call this variable endpoint. Now this variable is going to be a point in space, and we know that for a point in space to exist, we need to have x, y, and z. That's called a vector, okay? So in the variable type, we're going to change this to a vector type, and we're going to hit compile. I'm also going to turn this little eye, like droplet on so that we can see it, and I'm also going to turn this show 3D widget on right here, and I'm going to compile. What that will do, the little I button will make it public, so that means that we can change the variable at any time. And the little show 3D widget is going to show the little 3D widget on the screen. So now if I drag this fence right here, as you can see, there's going to be an endpoint right there that they can just select and just move around, see? So this is me adding a little bit of like, let's call this wiggling, well, not really, like customization to the blueprint, because we're going to be using this endpoint position to figure out where to place the next like fence. Okay, so let's go back here and let's start building our stuff. So the first thing I want to do is I want to create a little branch, and the branch is going to be like a condition, right? So we're going to say, okay, if something happens and it's true, then we're going to do something, and if nothing happens and it's false, then we don't do anything. And what is it that I want to do? Well, I want to check where the endpoint is. So I'm going to get the endpoint. And then what I want to do is I want to multiply this endpoint. I'm going to say vector times vector. Just times multiply. Oop. Is it this one? No, it's vector x vector. Where is it? There we go. Multiply. So it's vector against vector. So I'm going to multiply the endpoint by 1. And then, I actually don't remember why I have this node right here. Okay, no, I'm going to show you the other part of the script first, and then we'll come back to this. So what we need to do is, first, we need to add a static mesh, and that's what we're going to be doing. So I'm going to hit tab and write add static mesh component. And the static mesh component that we're going to be adding is going to be this wood fence. So that's the... actually, no, that's actually not going to work. That's really weird. What did I change here? 4. Oh, okay. Where is it getting this? Okay, yeah, I told you this was going to be a little bit bumpy. The right's going to be bumpy because it's been so long since I did this, but I want to show you because it's actually quite fun. So, again, here's what we're going to do. We're going to start with a little branch, and this branch we're going to be using it later on, but right now what's going to happen is when this branch occurs, when I construct this blueprint on the world, I'm going to do something called a for loop, okay? For loop is a, no, not for each, I'm going to do a for loop, there we go. A for loop is a very common programming concept that starts a loop, and every time it repeats that loop, you're gonna get like something, right? Like the body of the code that we write over here is gonna repeat itself. So the first index of the loop is gonna be 1. I'm at least gonna have 1 element right here. And what I want to do is I want to, of course, add a static mesh. So in the loop body, which is what's going to be executed, I'm going to add a static mesh component. Now, what component am I going to be adding? I'm going to be adding this wood fence A. Right now, I just want all of the fences to be the same mesh. So I'm going to grab this wood fence A, and I'm just going to drop it right here. And I'm going to compile again. So as you can see now here under the name, we get that, okay, this static mesh component, like every time this loop runs, I'm going to be adding 1 more segment of the fence. In this case, a fence A. Perfect. Now I'm going to say manual attachment, and where am I going to be attaching this component? Because if I just add it, it's just going to be there lost in the wind, right? I need to make sure that I add it at a specific point. And for that, I'm going to use another node called attach to component. There we go. Now, what am I going to attach? Well, I definitely want to attach this guy. This is this is going to be the target. Yeah, that's weird. Oh, it's not actor. Sorry, it's attached to component. So the node is called attached to component. Not actor again. Attach component to component. There we go. So the component is going to be this static mesh component, and it's going to be attached to something, right? I need to attach this to something so that if that something moves, then this one will move as well. And what I'm going to be attaching this to is this initial fence. Now, to make things a little bit cleaner, I'm going to change the name here to initial fence. There we go. Just drag this here, and this is going to be the parent. So again, what the body of this loop will do is it will add a static mesh component, which is the wood fence, to the scene, to this little blueprint, and it will add it where the initial fence is. Okay, it will parent it to the initial fence. Now I want to make sure that I know where to place this, because if I were to just go over here, I think it's actually like already adding it, but we're not seeing it because they're in the same position. So we want to displace this thing. We want to displace the whole thing a certain amount of degrees, right? Now, I know, because I can like drag my little mouse over here and get this information, that this fence is 417 units wide. That's the like length that we have for the fence. So what I'm going to go over here, I'm going to do is I'm going to go here to the for loop. And what I'm going to do is I'm going to multiply the loop by the size that I have, which in this case is 417. And then we're going to convert this into a vector. So I'm going to just drag this pin right here and say, we're actually, it's not, I'm multiplying index by index. I'm going to multiply by float. So times float. Index times float. Okay, I'm just gonna say float times float. That's really weird. Let's try multiply. Okay, so what I'm gonna do here is I'm gonna convert this into a float. No, sorry. Technically, I should be able to multiply this. That's really weird. Let's see. Where do we have float? Let's try multiply. Yeah, there you go. That's the multiply. But I want to convert this into a float. That's weird. Well, anyway, it should work with 417. So I'm going to multiply this by 417. And then I'm going to use something called a make vector. And I'm going to plug this pin into the X direction. Why the X direction? Because as you can see here, from this object, we're going to be pushing the object 417 units to one of the sides, okay? So that we match the other like distance of the object. And it's very important that we do 417 because that's going to be where the other like portion is going to be looping, right? So that's the make vector, and then this we're going to set something called set relative location. Set relative location. The target is going to be this new fence that we're adding, and the new location is going to be this one. Okay, so technically what this should do is we should be getting a second fence, and it should be being displaced 417 units to the right, and then doing the whole thing. I'm gonna say, for instance, here just 1. So the first index is 1, and the last index is 1. Hit compile, and there we go. As you can see, we get the second fence right there. Now, one thing we could do, if we don't want to like these things to collapse there because it looks a little bit weird, maybe we can add a little bit of distance, right? So here in the construction script, instead of saying 417, let's say 420. Nice. That's a joke. I don't do drugs. So we're going to go here, and we're going to have a little bit of space right there. So yeah, this little thing right here, this piece of code is going to be multiplying the amount of elements that we get here. Now, here is the kicker. Like now, what we need to do is we need to make sure that if we add a second index right here and we compile, it's working properly. And it is, as you can see. Now, the more indexes I add over there, the longer the fence is going to be. So if I move this fence all the way over here and I say give me 10 indexes and see it compile, now boom, we have this super nice like fence going all the way over there, and we don't have to manually place it because this little loop is doing for every single component, it's adding the component and multiplying it by the index and modifying the distance. Everything is working fine there, but there's a couple of things that we're going to be having issues with. So let's go back to something like a tree so that we can see this a little bit clearer. And one of the first issues that we're going to have is, or actually the rotation is working nice now. This was a bug back in 4.16 or something. When you rotate this thing, it would get like a different rotation. But no, it's working pretty nice now. That's cool. So we're not gonna have to add any. There was another like world rotation that we had to add to check and make sure that the rotation was properly working. But now it's working perfectly fine now. Now, I don't want to have to go over here and change how many indexes I want. I want this to be a little bit more what's the word? A little bit more dynamic, right? And that's where the endpoint comes into play. The little thing that we did at first, we're gonna do some work over here to make sure that the endpoints tells us how many indexes we're gonna have. So what I'm gonna do is as follows. I'm gonna grab my endpoint right here, and I wanna get the length. Like I wanna get what the vector length is. So I'm gonna say vector length. And the vector length is pretty much like the distance that you're gonna have on this specific point. Now, as we know, the vector length that we can get, let's compile this, is gonna depend on how far away this little point is from the rest of the elements. And I know, or what I want to have is if this element goes beyond a certain distance, that's when I'm going to get a new fence, right? Like that's when I'm going to be inputting a new little selection. So I'm going to be using something called a divide, float divide, and we're going to divide this by the size of the fence, which is 420, which is what we had before. And then I'm going to get something called a floor. Floor will just like collapse any decimal points into an integer. And that integer is what we're going to get here. So technically, if the endpoint's vector length is bigger than 420, we're going to get 1. If it's bigger than 840, we're going to get 2. If it's bigger than the next number, then we're going to get 3. And that way, we're going to know how many like loops we need on our element right here. So if I compile right now, as you can see, we don't get anything. But if I start pushing this thing, the more I push the little crystal, the more like little elements I'm gonna get. Look at that. Beautiful, right? Beautiful. So now I can make this fence as long or as short as possible, depending on where I push and pull the little endpoint. And yeah, that's pretty much it. Now, the one thing that this is not gonna work is this one right here. As you can see, the endpoint right here will only work if I push it forward, right, on its on the y-axis in this case. And I think I have another section of the little script over here, and I think what I did with that little section is being able to push this to the other side and then rotate everything. Let's see if it works. I'm gonna see if this works just very quickly over here, and if it doesn't work, we'll just go back. So what I did here was the following. I created something called a get actor location, So get actor location. There we go. And we're going to find something called find look at rotation, which is going to tell us which direction this actor is like rotated at. We're going to get the endpoint again. So get the endpoint. And we're going to add both vectors. And this is going to be my target, like that. Then from this, we're going to do something called a break rotator. And then we're going to make a rotator. I'll explain what all of this does so that it's a little bit easier to understand. We're going to connect the C axis here to the rotation. And then on the connections here of the completed effect, we're going to say something called set world rotation. Set world rotation for scene component. Set world rotation, default scene root. There we go. And then this is going to be my new rotation. Perfect. Hit compile. So now what this should do is if I move the point right here, the endpoint, the whole fence is going to rotate around. And depending on how much I increase the distance of the rotator, we're going to get this sort of effect. Now, it's not working exactly as intended because as you can see, it's not going exactly where I want it to go. But I think we can troubleshoot this. Now, let me explain real quick what this is doing. So I'm getting the actor location, and the actor is the blueprint itself. And I'm asking it, hey, where are you like rotating at, right? And it's saying, okay, this is the endpoint, and we're gonna add the vector or the position of this guy and the position of this guy, and that is gonna be like the average of the rotation that we're getting here. Then we're going to get the C rotation because that's the one that we care the most about, right? When we go here to the viewport, this rotation right here is what we care the most about. And we're going to be using that to like manage or say where this thing is going to be rotating. So that the average of both points is going to be the new rotation. And that's what's getting here on the set world rotation. So at the end of all of the indexes, at the end of all of the distances, we're going to set the proper rotation of the element. I think what I did here, which is just the final part of the procedural wall code, is this little section right here, and it's just telling it, hey, if the endpoint is not, it's 0. If the endpoint is 0, then don't create anything. It needs to be like bigger than X amount of number to create something. So yeah, I mean, I'm not sure we need that though. It's a little bit weird. But yeah, this is pretty much the code, guys. This is pretty much the code. So we have this little endpoint right here, and depending on when this endpoint is, the whole fence is gonna rotate around, and then if we push this on the x-axis, we're gonna get this sort of effect. I don't love the fact that it kind of like gets out of the distance, but it works. It's a nice little way to work. Now, here's the next like big question that some of you might have. Is like, well, that looks cool, but we have 3 fences. Is there a way in which we can like select from different like fence options, right? And the answer is yes. We can actually do that. But we're gonna have to do a little bit more stuff. Give me just 1 second. So, I had to do a little bit of digging because this is not something that I was expecting to add right now, but it's a cool little solution. I'm gonna show you here real quick. So what we need to do is we need to modify the way this add static mesh component works, because as you can see right now, this static mesh component is pointing to one specific mesh, which is the wood fence A, and we would like to be able to modify which fence we get from this section, right? So I'm gonna get rid of this one. So I'm gonna say clear. And now I'm going to add something called set static mesh. Okay, it's another little node here that we're going to be able to play around with. So yeah, this is what we're going to do. So this is pretty much like getting this option, the static mesh option, out of the node and into its own little node. So now here on the mesh, as you can see, we can select all of the different static meshes that we have on our project. What I need to create now is a new variable. So I'm going to go here to the variables, and on the options for the variables, we're going to go to object types. And I'm just going to look for static mesh. Let's see where it is. There we go. So we're going to create a static mesh, but it's not going to be a reference. It's going to be an array. And an array is a combination of several assets, okay? So we're going to call this fences. And I'm going to hit compile. Now here on the arrays, we're going to add 3 arrays, 1, 2, and 3. And we're going to plug in each of the fences as one of the arrays. So what I'm telling this little like variable is, hey, you hold the option to pick between all of these 3 elements. So you pretty much have the information of 3 different fences. Now, the only thing we need to do is we need to extract one of these meshes randomly to get one whenever we run this script. So I'm gonna grab this these fences, drag it here, get, and then there's a little node called get a copy. So right now, this get a copy is just gonna get whatever copy of the static meshes and drop it right here. Right now, it's getting a copy of index 0, which is the first fence, which in this case is fence A. Technically, if we compile this, our fence should still be working perfectly fine, and we should have all of the fences that we get, but it's still fence A, right? Now, to make this thing more interesting, I'm just gonna say a random integer. And the random integer, actually there's a little, it's called random integer from range or in range. And I'm gonna say minimum of 0, maximum of 2, right? Because we have 3 objects, and whenever you're dealing with programming, it's gonna be 0, 1, 2, like it's 0 based like order. And we just get this in here and hit compile. So now what's gonna happen is every time this code runs, it's gonna check a random number between 0 and 2, so 0, 1, or 2, and it's gonna select that static mesh from the array, and it's gonna populate our scenes. So now, as you can see, our element right here will have multiple different meshes. Now this will update every single time we move it, as you can see there. And sometimes we're gonna have the same meshes like on the same spot, but sometimes we're gonna get like different meshes, as you can see here. Technically, we could get like really crazy and try and find like a way to make sure that like they never repeat or whatever. It's just a little bit too much right now. it's a little bit out of my pay grade because I'm not a specialist in what's the word, in this sort of stuff. But the cool thing about this is now if we want to have like more fences, I can just like rotate this fence around, or grab this point right here, rotate this fence around, and just position it so that it has the same like distance that I need. Got it? It's still a little bit like unintuitive. There's something I'm missing on the construction of this whole thing. But yeah, it works fine. I mean, for like a quick construction here, it works fine. And if you have a game where you're gonna have a lot of fences, this is a really cool way to apply it. So yeah, that's it, guys. Hopefully you guys liked this video. I know it was a little bit choppy. This is usually not my expertise area, but I wanted to show you the way that this can work. And as you can see now, this asset is perfectly functional with the whole like a blueprint system here inside of Unreal. You can do this for fences, for pillars, for like walls. Like there's so many things, and that's one of the great things about blueprint editing, is the fact that you have so many options to play around with. So yeah, that's it. I'll see you back tomorrow, and for the next following days, we're actually gonna start with a mini project. I am gonna be working on something. I still haven't decided what, and we're gonna be doing that little mini project for the next probably like 3 or 4 days. Okay, so yeah, hang on tight, and I'll see you back tomorrow. Don't forget to like, share, subscribe. That's what helps us, and that's it, guys. Have a good one. Bye bye.